I thought I'd make a video explaining in full how to kind of work out the solutions for this 3.4 kind of skill, which really is a skill we went over in 3.3. I'm just making an extra special point to make sure we do a bit of practice with it. So, of course, we have three different kinds of angles we could find trig ratios for. We could find angles that terminate on the axis. They could have a reference angle that's in a special triangle, like pi by 3, pi by 4, pi by 6. Or the angle could have a reference angle that's not in the special triangle. So those are our three conditions, and depending on the condition, we do slightly different things. We take slightly different approaches. So we're going to work through a few of these problems. We're going to try and follow this flowchart. All right. So, question 1 is cosine of negative 4 pi by 7. Okay. So, the first step in our flowchart is to draw the angle in standard position. Okay, so the first thing we should do is draw negative 4 pi by 7. Okay, so we'll do that. So we know negative angles are drawn in the clockwise direction. And I like to start by just labeling my axes appropriately, like so. But I actually find one thing we've been doing in class that's been kind of helpful is just turning these into the denominators of the angle we're drawing. So instead of pi, 0, I'll write as 0 pi over 7. Instead of pi, I'll call it 7 pi over 7. And instead of pi over 2, I could call that 3.5 pi over 7. And so hopefully that helps us see that when we draw this angle, we're going to go past 3.5 pi by 7, but not too much further. Something like that. And that's our negative 4 pi over 7. And the question is, well, what do we have left? We've drawn 4 pi by 7 radians here in the negative direction. How much left is there to get to 7 pi by 7? And the answer is, was 4 pi by 7, so 5, 6, 7. There'd be 3 pi by 7s left. So that's our reference angle there. Okay. So we've drawn the angle in standard position. Does our angle terminate on the axis? No, it does not. Does the angle have a reference angle that we can find in our special triangles? So our special triangles are shown down here. We're pi by 6, pi by 3, and pi by 4. Those are the three angles we're kind of looking for. Our reference angle is none of those. So that means no. So that means we actually could not ever have found an exact value with this angle, at least not with the skills we know so far. We will learn some skills a little later on this year that will allow us to give an exact value of this ratio, but so far we don't actually know how to do that. So at this stage we're going to get a calculator out. We're going to make sure our calculator's in radians. This one is not. Oh, I should have done this beforehand. I don't really know how to turn this calculator into radians. God. This is going to be a great waste of footage. I apologize. Let's try one. No. Mode. Okay. Okay. 1, 2, 3. Here we go. Dang it. How do I do this? Alright. Linear. Okay. This is super frustrating. How do you turn this stupid calculator into degrees? Or, pardon me, into radians? Okay. Let's see here. Bit of shift. Oh, yes, okay. No, okay. 3. Oh god. 3. Okay. I don't really want to reset. It's probably right in front of me, isn't it? Engineer. Oh, found it. Okay. It's all the way down here. 2. Okay. R is 2. Alright, so usually DRG allows us to switch from degrees into radians. For some reason, okay. Alright. This is stupid. Are you serious? I'm just gonna give him a calculator. Okay. I can't believe it took me that long to decide to do that. Okay. Okay, so where were we? Sorry about that, guys. 4 pi by 7. Okay, so we just type it in for negative 4 pi by 7. Close bracket, and there we go. So this is a calculator question. So then we do cosine negative 4 pi over 7, which we found to be equal to 0. How many decimal places? 3 decimal places, so 0.223. Oh, and it is negative. I didn't notice that. Excuse me, got a bit of hay fever here. Okay, and so that's, again, this is a ratio. If I divide the adjacent side here by the hypotenuse, it turns out to be 0.2-ish. It's fine. All right, moving on to question 2. Tan of 3 pi. Okay. So for tan of 3 pi, again, first thing we do is draw our angle in standard position. And I've got 0 and 2 pi here, pi. And so I know I'm going to go pi, 2 pi, and then another pi gets me to 3 pi. So here's my 3 pi. And so this is a condition where my angle does terminate on the axis. So I'm going to use a unit circle here. So this is where, instead, I'll use a unit circle. So we have this rule that on the unit circle, when we draw it, of course, I'm only going to draw the coordinate I care about, which is here on my unit circle. That's the point negative 1, 0. And the rule is that tan is always the y-coordinate divided by the x. So tan of 3 pi is my y-coordinate divided by my x-coordinate, and my y-coordinate is 0, my x-coordinate is negative 1, so tan of 3 pi is 0. Okay. So we'll move on to question 3. So question 3 is sine of 3 pi by 4. Okay, so for question 3, we've got sine of 3 pi by 4. All right, so first thing we'll do is we'll draw it in standard position. So it's 0 pi by 4, and instead of pi, I could write this angle as 4 pi by 4. Instead of pi by 2 up here, I could rewrite that as 2 pi over 4. So that hopefully helps me see that I'm kind of dividing these into quarters here. There's 1, 2, 3, 4 pi by 4s, and we're going to draw this angle here. That'll take us 1, 2, 3 of them to this angle here, and that's 3 pi over 4. And the remaining reference angle here is pi over 4. And so if we look on our flow chart, we say, okay, this is the condition we might be more normal, more used to. We have an angle that doesn't terminate on the axis, but the angle is one of our special triangle angles. So we're going to draw a reference angle triangle to scale with this triangle, and we're going to use SOHCAHTOA. So our reference angle triangle will look like this, and I'm going to label it according to the 1, 1, root 2 of this triangle. So, of course, the only thing I have to watch out for is to make sure to make this side negative, because it is going in the negative direction from the origin. Okay. So this is a case where we are using our special triangles. And so here we say that sine of 3 pi over 4 is equal to negative 1 over square root of 2. And, oh, we should probably rationalize the denominator there, root 2, multiplied by root 2. So overall, it becomes negative root 2 over 2. That's our final answer. Oops, can't really see that there. There we go. All right, let's move on. So, question 4. The angle is 7 pi over 6. Okay. So we'll draw that out in standard position. So it's 0 pi by 6. Instead of pi, that we could call that 6 pi by 6. And so that already tells me if we're going in the negative direction. That's 6 of these pi by 6s. So we only have to go 1 pi by 6 more. However, if I could say, okay, I could go all the way around, that would be 12 pi by 6. We get some benchmarks here. And halfway to 6, I could say that would be 3 pi by 6, or negative 3 pi by 6. And if I kept going, that'd be negative 9 pi by 6. And that helps me kind of get a sense of where negative 7 pi by 6 is. It's probably closer to 6 than 9. Is exactly 1/3 of the way across. And my reference angle, well, I went to 6 pi by 6. I went one more, so that means there's a pi by 6 here. Okay. So just like the last example, this is an example where we do have an angle, a reference angle, that's found in the special triangles with a pi by 6 here. So we're going to label this up as a special right triangle. So it'll be negative root 3 here, and that would be 1, and that would be 2. And the tan is the opposite over the adjacent here. So this is a special triangle situation. And we'll say, okay, so tan of negative 7 pi over 6 is equal to the opposite over the adjacent, which is 1 over negative root 3. 1 over negative root 3. And so if we simplify that by rationalizing the denominator, we get tan of negative 7 pi by 6 is equal to negative root 3 over 3. Like so. Okay. So 5, okay. So there's a couple ways to go about 5. There's a fast way and there's a slower way. All right, so we'll start with the slower way and then we'll talk about the faster way in a second. So let's say I just wanted to draw this angle out in standard position. So the first thing I'm going to do is maybe I'll say, okay, well, if that's 0, it's the same thing as 0 pi by 3. And if that's pi, it's the same thing as 3 pi by 3. And 2 pi over here would be the same thing as 6 pi over 3. So, oh, there it is. So that means to draw this angle, I only have to go here. However, I might notice that reduces, right? 6 pi by 3. So if I can see something that can reduce, I might as well do it. So I could have actually expressed that as cosine of 2 pi. Because I could divide the 6 and the 3 by 3 to leave a 2 and a 1. So 2 pi. Okay, so the cosine of 2 pi, okay, this is a unit circle question. So I'll draw out my unit circle, but only the coordinate I care about, which is this one here, because we terminate on the x-axis, the positive x-axis. And that's the point 1, 0. And so cosine of 6 pi by 3 is equal to our x-coordinate, which is 1. Okay. So next we've got question 6. 6 gives us the angle sine, so the sine of angle 11 pi by 10. Okay. So we'll start with 0 pi over 10 over here, and this will be 10 pi over 10, which hopefully gives us an idea right away that we're going to 10 and just going a little bit further, and that's 11 pi over 10. I realized we didn't label this angle. That's 2 pi. And this is negative 7 pi by 6. Not good standards and practices not to label those angles. Okay, terminates. And if I find the reference angle here, that's a 10 and then one more to make a pi over 10. So this is a calculator question. We're going to need to calculate for that. So this is as simple as punching this into a calculator, because we can't get an exact value here. So sine of 11 pi over 10, and that will give us our answer here, which is negative 0.309, like so. Okay, let's do question 7. 7 asks us to find the tan of negative 3 pi by 2. So negative 3 pi by 2, so I'll start by just labeling up my axis here. That's 0 pi by 2 here. This is negative 2 pi by 2. And I can see here that that's going to be negative half of 2 pi. So negative pi by 2. And to get here, well, that's kind of the reverse of our regular scenario, which is positive 3 pi by 2. So to diagraph this angle, we end up terminating right here. That's an angle negative 3 pi over 2, terminating on the positive y-axis. This is a unit circle question. Okay, so for our unit circle, we'll just draw out the unit circle, but we really only need to label the coordinate we really care about, which is this value here, which is the value 0, 1. And we know that tan of any angle is the y over the x. If we can scale that triangle to the unit circle, this would be y over x, which is our y coordinate is 1 over 0. And if you divide 1 by 0, well, you cannot do that. This is undefined. This does not exist. So, moving on to question 8 here. Question 8 asks us to find sine of 8 pi by 3. Okay, so question 8. Sine of 8 pi over 3. Okay, so to draw that in standard position, that's point angle 0 pi by 3 here. And instead of pi, I'll call it 3 pi over 3 over here. It says half of pi by 3, so it'd be 1.5 pi over 3, I suppose. That'd be a weird way to express it, but I mean, and to go all the way around, that's 6 pi over 3, and we can see we're going to go a little bit further than 6 pi over 3 here. Okay, so maybe we'll go all the way around 6 pi, 3, 6, and we're going to go 2 more thirds of pi. If we go another third of pi, we're going to get back to 9, so we're going to end up here, and that's the value 8 pi over 3. That's the angle 8 pi over 3. Which means if we added 1 more pi by 3, we would get back to this axis. And this is one of our special triangle scenarios, which we're probably pretty familiar with at this stage. And so we're going to label it accordingly. And so we find this is a special triangle situation. It's a sine 8 pi over 3 is going to just become the opposite over the hypotenuse, which is root 3 over 2. And we don't need any rationalizing of the denominator or anything like that. We're done. Okay. So this question gives us the value cosine of 3.141592653 ... which we can see is probably a familiar sounding number, but if you check on your calculator, you're going to see that it corresponds fairly closely to the value of pi. And if you were to round this up, you would find it's the exact value of pi that's shown on your calculator, which is actually a rounded value. So this is another way of saying cosine of pi. So we can draw that angle, and so we'll call that 0, and this is pi, 2 pi, and so on, but we don't have to draw much more to know that we need to get here, right? That's pi. That's pi radians. Okay, and so that makes this is one that terminates on the axis, and so this is a unit circle question. Okay, so I'm going to draw that unit circle, and of course cosine always corresponds to my x-coordinate. So that's the point -1, 0 here. Okay. And, alright, so cosine is always your x, so in this case your x value is -1. And we can always verify that, right? So let's just try it. Cosine of pi is -1, so our calculator can back us up on that case. Alright, so tan of 0, this should be an easy one to draw. Tan of 0. So in this case, it doesn't really matter if we're even in radians. So we know that to draw tan of 0, we just have this value here. And it turns out to terminate on the axis. And so we can think of this as a unit circle question as well. And again, we only care about this value in this case, which is 0.10. If we draw our unit circle out. And the tan of 0 is our y-coordinate over our x-coordinate, which is 0 over 1 or 0. So tan of 0 is just 0. And if we check on our calculator, we can confirm that's definitely true. So tan of 0 is just 0. Okay. Alright, so we'll get that last paper here. Getting there. Alright, so question 11 asks us to look at cosine of -2 pi by 9. So we're going to draw that angle out. So we're going to subdivide our coordinate plane here into 9ths of pi, which makes this 9/9 of pi to go halfway around. And of course, to go all -9/9 of pi, and to go all the way around, it would be -18/9 of pi. But we only want to go 2/9 of pi, so we're not going to go very far. We're only going to go like there, basically. That's the angle -2 pi by 9, and the reference angle, our reference angle is actually just a positive version of that angle. Okay, either way, this is not an angle that shows up in our special triangles, so this is just a calculator question. So we just punch that in the calculator. Cosine of -2 pi by 9, cosine of -2 pi by 9. And so we get 0.766. Oh, I realized that last part was off of the screen. I do apologize. I think I do that a lot. Alright, so let's move on. Question 12. So 12 asks us to look at sine of 5 pi by 4. And so we can label this guy up. So it's 0 pi by 4. That would be 4 pi by 4. And so already we're probably thinking, oh, okay, well that must be halfway to 4, and this must be 2 more pi by 4s. And this is 8 pi by 4. Okay, and so we're going to go 1, 2, 3, 4, but then we only have to go 1 more pi by 4, and that's the value of 5 pi by 4. the reference angle here is actually just pi by 4. And that looks like a special triangle situation, right? That looks like our 1, 1, root 2 triangle. We've got to watch out for those negatives, of course. So this is a special triangle situation. Special triangle. And so that means that sine of 5 pi by 4 is the opposite over the hypotenuse, which is negative 1 over root 2. And when we multiply by root 2 on the top and bottom, we actually find that sine of 5 pi by 4 is negative root 2 over 2. Like so. Okay. So 13. So this is one question where we can actually see that before we even get started, we're actually just talking about an angle that's in our special triangle. So I don't even need to use any sort of special polar coordinates to make sense. Translate this angle into a right angle triangle. It actually fits inside a right angle triangle. It's a right angle triangle I'm familiar with. So this is a tan pi by 6, and we can see that actually it's just going to be the opposite of the hypotenuse, which is 1 over root 3, which when we rationalize the denominator becomes root 3 over 3. All right. Last one, 15 pi by 6. Okay. Cosine of 15 pi over 6. Okay, so the first thing we'll do is we'll draw it out. So instead of 0, I'll call it 0 pi by 6. And instead of 2 pi, I'll call it 12 pi by 6. Oh, so already I can see I'm going to go further than here, but I'm going to label up a few more of these to help give me some benchmarks here. So we'll call this 6 pi by 6. That's halfway to 12. That makes this 3 pi by 6 and 9 pi by 6. Okay, so I can see I'm going up by 3s, which means I can see I'm actually going to get it up here eventually. So 1, 3, 6, 9, 12, 15 pi by 6. Now, at this stage, I might notice actually by going, both these numbers are divisible by 3. So if I wanted, I could simplify that. So it's actually just, maybe a simpler way to look at that is actually 5 pi over 2. Half a pi once, another half pi makes me pi, another 2 half pi's gives me 2 pi, 5 pi. Okay, anyways, that's a unit circle scenario. So to solve it, I'm going to draw the unit circle with the value I care about, which is up here, which is 0.01. And cosine 15 pi by 6 is, cosine is always the x-coordinate, which in this case is 0. And I can confirm that with a calculator. Cosine of 15 pi by 6 gives me 0. Okay. So that's it. What's important isn't really any one of these questions, but just being comfortable converting any of these when need be, no matter kind of what scenario we're in. So pivoting along this sort of flowchart. All right, well, good luck. Enjoy the rest of your spring break. Don't work too hard. And we'll see you when you get back.